All right, let's look at number 12 here. This is our familiar tabular, analytical, numerical, and graphical representation of a situation that we need to, which enables us to look at a situation and be able to represent it in multiple ways. So it looks like in this problem, we were given what the numerical part is. You need to be able to give me, provided I give you one of these squares, one of these boxes, whether it's the tabular, the analytical, the numerical, or the graphical, you, as a student endeavoring to master Algebra 1, need to be able to give me what the other three boxes are. So, it looks like in this review, you were given the numerical equation. Y equals 5x plus 3. Y is the dollars spent. X is the number of tickets sold. Well, I like to start at the table. So I'll just go ahead and label these our X and Y. X is number of tickets. And Y is our money spent, which makes sense because number of tickets is our independent variable. Remember, X is our independent variable. The amount of money we spend is dependent on how many tickets we buy, and Y is always our independent axis. It's our independent variable. So I'm going to write 0, 1, 2, 3. So using our equation down here, our rule, I'll just rewrite it up here, Y equals 5x plus 3. When x equals 0, Y equals 3. When x equals 1, y equals 8. When x equals 2, y equals 13. When x equals 3, y equals 18. Does this make sense? Well, each time we're increasing by 5, and over here we increase by 5 whenever this increases by 1. So yes, our rate is 5. And when x equals 0, when we back our pattern up to 0, remember, we always back our pattern up to 0. We had $3, and yes, our constant is 3. So our table matches, our table makes sense. It matches our numerical equation. Analytical word problem, all you need to tell me is that Wow, I do not know why it opens 3 of these every time. Our analytical word problem, you just need to tell me we had $3 to, we already spent $3. We spend $5 additional per ticket. This $3 is our constant amount. This $5 additional per ticket is our rate. So let's go ahead and... Okay, so here's our table. I rewrote it here. And so what's nice is that if you go ahead and write your table first, it's easy to plot the graph over here. So our first point is 0. At 0 tickets, we already spent $3. 0 tickets. Let me move this down. At 0 tickets, so we can go ahead and label our axes down here, 0, 1, 2, 3, 4, 5, 6, 7, and dollars spent, $1, $2, $3, $4, well, we should probably, because see our domain is 0 to 3, our range is really 0 to 18. So it looks like we can count by 2s here, 2, 4, 6, 8, 10, 12, 14, 16, 18. So Zero tickets cost $3. 1 ticket cost $8. 2 tickets cost $13, and 3 tickets cost $18. 3 tickets. Looks like you got a third wheel there on your movie date. Alright, there we go. And that's what the graph looks like. Remember, quick review, this would be our domain because this is on our x-axis. This would be our range because this is our y-axis.